G'day again. Today we're going to look at the advanced sine rule. So the advanced sine rule says A over sine A equals B over sine B, and it actually says equals C over sine C. But you don't usually use this part, so we're not going to worry about that. Because when you're doing algebra, you usually only want to solve for one missing thing, and you only need one other angle and one side, and you've got the solution. So while that's true, that it does equal C over sine C, you don't need it to solve problems. What you need to do, so for this one we're going to find the sides. So I've labelled this A to make life a bit easy for us and called this A. When you're looking for a side, you want to put the side on top. Now this formula is given to you on a formula sheet, so it's very easy to look it up and use it. So here, this is side over angle. In any triangle you've got, if that's an angle, this is the corresponding side. If we put another one in, if that's an angle, that's the corresponding side. So the sides and angles correspond to each other. If that's the side, then that's the corresponding angle, okay? So they correspond by a crossways. So when you're looking at where is sine A, where is A, you've got to look at that sort of thing. That's A, that must be sine A, because they're directly opposite each other, okay? So let's have a go at solving this. So we're going to go so the side A over sine A, which is sine 50 because they're opposite each other, equals B, so that's the side, 30 over, and the opposite to that is the sine 40. Okay? And how do you solve it? Well, it's basic algebra. Whatever this value is here, that value is going to go up there. So we're just going to multiply, effectively what we're doing, multiplying both sides by sine 50, cancel there, and putting it up here. So we're going to get A equals 30 over sine 40 multiplied by sine 50. Punch that in your calculator, and where is a calculator? Let's grab one. Whoop. There we go, there's a calculator. And we're going to go 30 divided by sine 40 multiplied by sine 50 equals, and we get 35.75. Okay, 35.75. And that's centimetres, and that's your answer. You're done. So we'll look at another one in just a sec. G'day again, back for a second one. So A over sine A equals B over sine B. Here I've just changed the diagram around a little bit, and you might look at it and go, okay, I've got this over this, I want this over this. Oh my goodness, there's no angle there, I can't do the question. But you can. It's pretty easy. You've got a triangle, you know this angle and this angle, you're only missing one angle, so it's not too hard for you to figure out, oh, I can take away from 180. So if you go 180 minus 50 plus 50 is 100 equals 80, well, you know that angle must be 80. So let's write it in there. And now you've got your two diagonals that you can use for your equation. So let's go ahead and do it. So instead of A over sine A, we're going to use X. So X over sine 80, not 86, 80 equals 70 over sine 50. Since you've seen it once, you might want to pause the video and see if you can get the answer before me. So then we go X equals, and I'm going to multiply both sides by sine 80. So 70 over sine 50 multiplied by sine 80. Punch that in your calculator. I've got my calculator here, and I've actually just done that one. And we've got 89.99 centimetres, and that's the answer for the length. And you're done. G'day again, back for part 3. So for this one you'll notice I've flipped the equation upside down. And why would I do that? Well, in this case we're looking for the angle. Now you're not usually given this in an exam, you're given the way I wrote it before, which is this, A over sine A equals B over sine b. But you can flip an equation because you're just changing both sides of the equation at the same time and it doesn't change anything. For example, if you wrote 3 over 4 equals 6 over 8, which you know is true, that's the same. It's an equivalent, okay? Nothing's changed. You've still got 3/4 equals 6/8, well 4/3 equals 8 on 6. Same applies with equations. So nothing changes in terms of the value. I mean, the value of that actually changes, but the equivalence doesn't change. Okay, so that's something for you to understand about mathematics. Change both sides at the same time. No values change. Right, so we're going to use it this way. Let's have a go. So we want the thing we want to solve on top, and in this case, that's our angle. So again, you might want to pause this and see if you can beat me. So, or just check your answer. Sine theta over 80 equals, because there's our opposite. Okay, angle over side, so angle over side equals sine 50 over 70. And this thing on the bottom is going to go right up there. So we're going to put it up there, and you go sine theta equals sine 50 divided by 70 multiplied by 80. Punch that in your calculator, and I haven't done that one. Better do that one now. So we're going to go sine 50 divided by 70 multiplied by 80 equals, and you go, that's 0.8754. So that equals 0.8754. Now that's one step to do it. I think an easier one, and now you can press shift sign of that. I think it's easier if you press the whole lot all at once. So instead of doing that and now pressing shift sign on your calculator, I think it's much easier if you just do it all in one step. So from there, you would press on your calculator shift, because we want this. We don't want sine. We don't want that 0.8 thing. That's not the answer. We want the value of that. So shift sign, brackets, sine 50 over 70 multiplied by 80, close the brackets, press the equals button, and then you're going to press your degrees, minutes and seconds button. Okay, and that's going to give you the correct answer. So then you'll have theta equals, and you don't need to write this, you just need to write this. It's good practice for you. So we're just going to press shift answer. Oops, let's just do that again. Answer equals degrees, minutes and seconds, and we get 61 degrees and 6 minutes, and you're done. G'day again. So we're going to do some more on the advanced sine rule. So we've got our diagram here. We've got theta 19, 110 and 24. They're opposites, so let's do it. So we're going to have sine theta all over. What's opposite the theta? Well, it's 19, isn't it? So that's the one that's on the bottom. That's going to equal, this one's sine 110 over 24. So we've got sine 110 over 24. Now what do we do with that 19? Multiply it both sides by 19. It'll cancel here and it'll go over to this side. So just put a little arrow. So sine theta equals sine 110 over 24 multiplied by 19. How do we figure it out on a calculator? Again, we're going to press shift sign of all of this. So we're going to be going shift sign of all of this stuff. So sine 110 over 24 multiplied. Make sure you put your brackets in there, because calculators often absorb this bit into your equation. Press the equals button and then press your degrees, minutes, all right, DMS, your degrees, minutes and seconds button, and that should give you an answer. In this case, we've just done that. We got 48 degrees and 4 minutes. Pretty straightforward. Now I'm going to show you something if we change things around just a little bit, but we use pretty much the same diagram. Now having done this, we know that this is pretty close to 48 degrees. And we know that with some accuracy because we've actually done it. So let's write 48 degrees there. And we're going to change this and find out what this is. So we had it as 110. Let's see if we get close to 110, if we change that to theta, and let's do all this again. So this time, our sine theta is there, and what's opposite it? 24. So I'll put a 24 down here, equals. Now we've got sine 48 over 19. I'm going to multiply this across here. So sine theta equals sine 48 over 19 multiplied by 24. We're going to punch the same thing in our calculator. So shift sine bracket sine 48. Make sure you close that bracket. 19 multiplied by 24. Close the bracket. Press the equals button. Press your degrees, minutes and seconds button. And guess what happens? You get theta equals, and we've just done it, you get 69 degrees and 50 minutes. Or actually 49 and a few others, but rounds to 69.50. Now how did that happen? We know that that should be 110 because we just did it. It can't just randomly change and lose all these degrees, can it? That's impossible. So what's actually happened is on your calculator. Your calculator only works to 90 degrees in doing this calculation. So in doing this calculation, your calculator's working to 90 degrees, and it's based on the sine curve. So there's your sine curve. It's working to here. So when it gets a value here, it automatically moves it back here. Now, I didn't program your calculator, but that's what usually happens. So when you've got a bigger angle, an angle greater than 90 degrees, what you have to do here is then say, okay, I'm going to go 180, because that's not actually what theta equals. Theta really equals 180 minus 69 degrees, 50 minutes. And if we do that little equation, we get 110 degrees and 10 minutes. Actually, I mean, if you did it based on your calculator, you get 110, 9 and some seconds, but it rounds to that. And that is pretty close to our answer. So just watch out for that when you're using this on your calculator, because it can give you the wrong answer if you're not aware. And you're done.